Hello, and thank you for joining us. My name is Doug Riches. I'm the Vice President of Architecture and Innovation here at Rangle. I'm super excited today to spend about an hour with you folks. We're going to talk about micro front ends, which is somewhat of a new topic, kind of rolling around the internet. So we wanted to talk to you a little bit about what that is, how you can use it, and different options that you might have. Really, when you think about it, building large-scale software is hard. Too often, I'm talking with companies that are stuck with hard-to-change, large, monolithic applications. And it's kind of like an old wool sweater. You pull on one string and the whole thing becomes unraveled. Building web and mobile apps doesn't have to be hard or like that sweater. I'd like to share with you some ways you can avoid these pitfalls today and what you should be looking towards in the future. I want to make sure we get into the meat of this, and that one thing is clear. In software, there's many paths to success. What I won't lecture you on today is test-driven development or code reviews. Those are really important things, but what we are going to focus on is JavaScript application architecture patterns and what the future can look like if we so choose. What I'm talking about today is one path. But you may have a different way that works for you, and that's okay. In fact, I'd love to hear from you folks at the end to actually see we'll have a question period at the end, and I'd really love to hear from you. If you have different questions or different ways that you might approach this, I'd love to hear from you on that. So let's get started. Okay, I want to take a few minutes to talk about some things that really matter. So when we think about building applications, as developers, as technologists, often we think a lot about the code, we think about testing, we think about things like architecture patterns, but there's a lot more that matters when you're building an application that you need to consider. And this is part of why micro front ends really start to matter. So let's start from the user. I mean, really, when you're building applications, you want to remain user-centric. So design and user experience, it really should be kind of at the foremost of anything that you're building as far as priorities. As well as speed to market. You want to make sure that the features and functionality that you're building for your app, no matter what industry you're in, really you should be able to get those features to your users very quickly. The rate of change and demand that users have today versus what they had even 5 years ago has really, those expectations have really risen. And we need to make sure that when we're building features that it gets out to market very quickly. Of course, hand in hand with that is return on investment, because as technology leaders, we need to be able to build these applications, these pieces of software in a way that is monetarily going to make us successful, as well as developer happiness. When you think about having a team that's working on software and being successful, part of that is having developers that have a great environment to work in. They feel like they're actually achieving the goals that the company has set out, and they're actually making progress on building these features and having them released. Nothing feels better than going home at the end of the day and having something that I accomplished something today, something's gone live. And part of that happiness comes from a maintainable architecture. So something that isn't difficult to make those changes. You're not spending weeks and weeks, like I mentioned with that sweater. You pull on one string and the whole thing becomes unraveled. And then additionally, code portability. So a lot of clients that we talk to, they end up in a situation where they have more than one application, and they don't want to be reinventing the wheel. It goes back to that ROI. The developers wanting to not build the same thing over and over and really solve kind of new problems that matter. So when you think from a holistic perspective about your applications, these are all things that really matter. When you think about delivering on things that matter, really, in the last few years, specifically from a JavaScript perspective, there's been a lot of different frameworks and libraries out there that have really come to light. And this talk is all about choice. So we're going to focus when we're talking on this on the three major players within the JavaScript community. So we have React, Angular, and Vue. All of these frameworks and libraries really provide a really great set of tools for you to build efficient applications. But sometimes they don't go far enough, and that's really what we're going to focus on in the next upcoming slides. Before we do that, though, there is a survey that we have inside the software. If you can take a minute to actually answer the question. There we go. There's there's our survey. So we have a quick poll. So basically, which of the frameworks are you using? And what do those look like? So we have Angular, React, Vue, AngularJS, which is Angular 1, of course, or are you using something else, something that's not JavaScript or a different library? So that would be great to understand. I'm just going to flip back to the poll now. Okay. So all of these frameworks are working towards the goals of allowing us to build amazing things in the browser. There's a few universal attributes that we want our applications to have: performance, speed, accessibility, code reusability, separation of concerns, testability, good user experience, good developer experience, and flexibility in features and code. And each of these frameworks takes different approaches to achieving all those goals. Let's take a step back, though, for a second and understand how we got to this place where we need to talk about this thing called micro frontends. When I started in the industry years and years ago, probably in the 90s, I'm not going to say that for sure, it was the tech team. We had a singular team. Really, tech teams were building across multiple different types of, so you might be doing Java and CSS and HTML all in the same day because you were part of, a singular monolithic application. And as a developer, you were developing everything. In the early 2000s, we switched a little bit more to specialities. So we started to see the front end team and the back end team emerge. And so we would see people with specialities in development in HTML, CSS, JavaScript, and you might have Java or .NET on the back end. But still, we ended up in a case where on the back end and on the front end, we had these large kind of spaghetti code style applications where there was a lot of tight coupling between everything that was happening. And the back end teams, really started to look at it and say, hey, you know what, there's probably a better way to do this. There's a better way for us to divide the work up. And so everybody's heard about, the term microservices. That was really one of the main approaches that the back-end team started to adopt to really start to allow us as developers and application companies to separate out those concerns, really, focus on things that matter with the client, and then, provide that information to all the different UIs that might be ending up using it, whether it be that mobile or web, etc., kiosks. The front-end teams, to some extent, followed and started to build some component architectures, but really, they for the most part, applications stayed somewhat monolithic. They became large applications on the front end that went through some sort of composer layer. Be that Node or a Java, or even more modern applications are using things like GraphQL to impart that information to the front end. But we still have a little bit of a monolith today on the front end. So what are some of those things that we do today? We have design systems. Design systems allow us to really kind of focus on building the right thing across multiple applications, across multiple features. We have isomorphism, so we have the idea of JavaScript that is rendered on the back end and displayed on the front end. We have shared code bases, so you might have a component library, etc., and that can be shared across multiple applications or even multiple teams. We start to have a separation of concerns. So across Angular, React, and Vue, we start to separate service logic out from UI logic. So we're starting to see some of that monolithic kind of tendencies that we have in our applications being separated out. All of the modern JavaScript libraries, of course, handle unit testing. Testing is just as important as code, as well as state management. So we start to separate out, what the application is actually doing from the UI, which allows us to make that code more portable. And of course, immutability is a big part of that. A big part of what I just mentioned is a component architecture. Stateless components are really kind of the biggest thing that has kind of driven change within the JavaScript community in the last 3-4 years. The goal of this architecture is really to build applications that follow functional programming patterns. Each component is a black box that only has actions or styles or data or properties passed into it, and its features are somewhat self-contained. And this type of architecture today, we typically have Redux, NGRX, or Vuex in Vue manage the global application state. But still, we end up with applications that are very large and tightly coupled to data. So, the ease at which we build mobile and web apps has increased dramatically over the last 7 years, like I've mentioned. As each library or framework improves in capabilities, they diverge in approach. How Angular approaches something versus Vue or React is different. This leads for an inability to easily change technologies as business or user needs change. And we can find ourselves in a state in large applications where projects become increasingly inflexible or brittle over time. So what's our solution? How do we solve these problems, which is what everyone's, I'm sure, but chomping at the bit for me to get to. This is what the modern application approach really should look like. And what's interesting is, we've talked about this for a while, but now it has a name, this micro front-end name, but what it comes down to is vertical slices of functionality, separating out your application into things that matter to front-end users, separating out your teams according to those slices. And then you have teams that can work straight through from the client side, straight through to the back end in a single slice of code, so they can develop features independently of the other teams. We start to slice that, this diagram only has 3 slices in it. In a large complex application, you might have multiple teams, 10 teams that are working across different things. So just like the microservices, like I said, they're made of cross-functional disciplines from Scrum Masters, visual and UX design, product strategy, JavaScript, and server-side developers. Each application works and is deployed independently. The browser DOM becomes the API through which they communicate versus actually communicating through understanding what the other application is doing. And we're going to get Tim in a couple of minutes to actually go through that. So what are some of the core concepts of micro frontends? So there's a couple of different things that we look at. Code isolation is really one. So the code really should work independently as a micro app within a larger application context. The application for accounts, so we're going to look at a banking example later, for accounts should be separate from credit. We should be able to be technology agnostic. So each team can select whatever tools best suits their needs, both from a business and a user perspective. We should utilize browser events to facilitate communication so that those applications don't need to know about what is happening somewhere else in a different part of the application. We use component libraries, again, using web components so that each team is able to actually develop according to brand standards consistently without reinventing the wheel across different lines of business across the enterprise or organization. We start to use things like feature flags so that if one team has a set of features ready but another team doesn't have them ready, they can deploy their changes out there, and as soon as that global application is ready to go, we can turn application features on and off. Of course, all of this, there's complexity that happens. So having a good DevOps flow and workflows is really important to make sure that each team is able to deploy applications out separately in an efficient manner so that we can get to market quickly. And of course, like I mentioned before, immutability, that idea of one application not knowing what the other application is really doing on the inside. So what might that look like if we kind of looked at it today? This first approach I'm going to show you is really a kind of a single framework approach to a micro front end. And today, many of the apps that we build are in fact single framework micro front ends that check a lot of the boxes that we've talked about as far as kind of requirements. There's a couple of boxes for very large teams that don't get checked here, and I'm going to talk about that in a second. But this approach, really what we're looking at here, requires everyone to work in React. We can split up into vertical teams that work in separate parts of the application with either namespace Redux state or even a separate state. In fact, most of what I talk about next applies to the same as in this case, except everybody in this case has to use React. So we have a design system that feeds a React component library. We have team components that are assembled that are immutable and really kind of, the other components don't really know what's happening inside of them. We can even have namespace states, so each application manages its own state internally, and then code splitting allows us to deploy those applications separately but come together as a larger whole later. And don't get me wrong, there's nothing wrong with this approach. We do this approach often with our clients as we work towards really trying to make sure that we're able to deploy features out quickly and effectively. And different organizations have different needs. In different larger organizations, very large organizations, perhaps even with hundreds or even thousands of developers, this kind of approach might be unwieldy because we don't have the flexibility of choice. So the next example we're going to show you here is a more technology agnostic approach. It is possible to have each team or vendor, if you're working in that kind of model, build with different tools independently. And what's different comes in three major areas. The core component library is written with web components, so it can work with any framework. The DOM becomes the primary method that the applications send messages, so via events or via the actual DOM itself through properties. And then we can utilize server-side includes as well for performance and ease of integration across all these different types of applications. The result that we end up with is that we can have separate teams working towards their goals independently without stepping on each other's feet. And regardless of whether you choose a single or multi-framework route, the result is your application is not a monolith. You're able to actually slice up the application into logical vertical slices that make sense, and you're able to much more quickly get features to market. So and Tim is really going to show you an example of this with React shortly. So what does this actually mean? One of the most important things that can come out of this is when you have this last approach where you have a component library, you have, really it's JavaScript that's the, core JavaScript that's driving and web standards that are driving your applications. You can have one team working in React, you can have another team working in Angular, you can have another team working in Vue, and at the end of the day, all those applications, all the work that you put together can come together. You could even have a team that purely works in web components and get the same results. So what does this look like? This is you'll have to excuse my drawing because it's not what I do. This is a banking app, and what Tim is going to show you is how this can actually work in reality. So in our example, we're going to be using React and web components to show you this, just for simplification of the amount of time that we have. But each team can separately develop different parts of the application. So we can have an account team working on the bank accounts, transactions, and charts for that. We can have the investment team. They can work on a different set of data, a different set of services, and they can display their part of the application differently and really apply different logic to what they want to do. And finally, we have the credit team that is going to, show credit balances. So how much money I actually owe to the bank versus how much of my money they have, and maybe have an apply now link, as you can see in the diagram we're showing here. So each team is able to actually develop separately, but still come together as part of a larger whole, which is powerful when you think about the ability to move quickly. Instead of having to have all these teams coordinate and work together towards a common goal, they can do their individual goals as part of a larger whole while still keeping consistency, while still not reinventing the wheel every single time. So with that, I'm going to pass the reins over to Tim, who's going to walk us through a demo and really show you the guts of how this can work from a code perspective. Tim?
Thanks, Doug. My name is Tim Ludikar. I'm a Director of Architecture and Innovation here at Rangle, and I have the pleasure of walking you through our brief little demo on micro front-ends. First off, before I dive into it, what I'd like to kind of throw a little bit of a caveat on there. This isn't necessarily a demo or code repo that's going to demonstrate the world's best code quality. There are no unit tests, and I will also say I'm not a designer. So unfortunately, the designs are basically following what Doug gave me and aren't necessarily the best. But what we do show you in this demo is a really strong front-end application architecture that does break down to that, leveraging the DOM as an API, and allows you to kind of finally break down into those silos as you normally would want to. So what I'll do first is I'll pull open our application, and I will say, unfortunately, being a micro front-end application, there are really 4 different types of applications that we're looking at here. The first one is going to be, or I should say my bank app is going to be sort of your combination layer, and this is where everything will sort of come together and actually be the final product that's assembled for your clients. We have our component library. Now this is going to leverage things like your design system, and once these components are created and follow your design rules, they can be imported into any of these apps and leverage the same look and feel and brand consistency, and ultimately help you with your performance later down the road. And then we have things like our account application, our credit card application, and our investment application. So first off, if we start to take a quick look at the components, we'll see here that we've broken it down. We have things like a chart, we have a grid, we have navigation, we have headings, we have a table and section. Now, some of these are not necessarily going to provide a lot that we'll see visually, but they might provide things like accessibility. They're going to follow those brand guidelines that are going to be required. Something as simple as headings allow us to enforce that typeface that we would want throughout our entire application to be consistent. And it means that basically those siloed teams don't necessarily have to worry about messing around too much with the actual inner workings and the styling of them. It gives your designers and your marketing team the nice, comfortable feeling that, what they design is going to be what's going to be on the web. All of these have been kind of created leveraging Stencil, which is an Ionic framework. And the reason we wanted to leverage Stencil for this situation, although it doesn't necessarily play the best with React, it allows a lot of features out of the box that we can leverage with, like, say, TypeScript and unit testing. And it provides a very nice interface to actually getting these developed and built, and give us a nice bundle at the end of it without having us to think about it too much. If we look at, say, something as simple as the my chart.js here, and I'll expand this, you can see at the top we're actually leveraging chart.js. We've created an interface that works for all of this. We're linking in using the decorator here for the component. We're establishing what the tag is going to look like and what the CSS will also connect with. As we kind of roll through it, we are leveraging and displaying things like what props are going to be available and what methods will be available. We could leverage things like TypeScript a little bit better. That's, again, my coding practice, unfortunately, here. That we can kind of make things private and protected and public as necessary. Basically, this one component is just here to give us that interface into chart.js. If we look at some of the other ones that we have here, they can be very light, they can be very heavy. Again, this is just leveraging something very simple. Our headings component basically just gives us the ability to specify if it's going to be an H1, an H2, a P tag, or anything like that. And we've set some nice defaults here. We've also leveraged things like Storybook. And the benefit behind Storybook is that as you open this up and these components to your verticals, you are able to give them the tools to kind of play around with it and see what it's going to be like as they start to build or formulate what they need to actually create in their application. So I actually have a very brief demo here with Storybook. If we open up this, you can see very simple. We have my bank heading component. In this case, it's just kind of specifying the size and everything that's going to go through. We're able to come in here and change it just so we can kind of get a feeling of what the text would look like, and it's all going to update as it goes through. We have things like the pie graph. So again, this is all leveraging web components. One thing to kind of call out is that we are on a very strong alpha release for Storybook to make this work, but it is functional and it seems to be working quite well. We're able to adjust and dial in the data sets if required, and generally play around with this. And this gives your developers that ability to look, pick and choose, and it gives your designers the consistency knowing that it's going to be what's going to be implemented. So with this, once we build this down, we're actually able to take these components and bring them into our micro apps and into our verticals. So if the first one I bring in and I take a look at here is the account application, all we've done to kind of bootstrap this is I've customized very briefly a React create a React app with a certain script that allows for TypeScript and some compilation. What we do is generally the industry practice for building a component or a library is to leverage a build application called Rollup. And if you're building an application, it's much better to leverage, say, something like Webpack. So in our micro apps, we want to leverage, basically want to leverage Rollup so that it has that exportable thing that can be consumed kind of throughout the combination application. So if you look at this and kind of how we all break this down inside of our source, again, I apologize, it looks a bit messy. This will be available on GitHub, and I'd encourage you guys to follow it. We will be updating this as we go through and cleaning this up. Here, we're actually bringing in and importing the My Bank components, and that basically gives us all of the, my navigation, my table, buttons, and things like that. In order to make this work or make some of the web components work with React, we've had to create a bit of a wrapper. So as you can kind of see up here, we have imports from pie chart and from table. And they're very, very simple and very straightforward. If you see what we're doing here is we're integrating into the React component lifecycle to establish and put some of these things out. So generally we know what's going to be rendered out. What we have to do is basically insert the data like we would through a regular DOM application. So this leverages the React lifecycle areas such as, or API I should say, such as component did mount, and installs the data as required passed in. And then we have to leverage such things as, component did update if we need to update or redraw that chart. Table is very, very similar, and it's the same thing here. The only difference that we have in this situation is we want to be able to encourage clicking inside that table to highlight new data inside the chart. And that's basically what the application is looking to do. So as we come down to how this all gets interfaced, you can see very similar, or very straightforward, I should say, that this piece of code down here is what will build your micro application. In here, we've got things like our grid, our headers, and headings, the table, and the pie chart. And all of the state is kind of stored in this application and kind of passed in and out. The benefit to this is that as a team goes ahead and builds it, we're actually able to come in and actually start that application by itself as a standalone. So if I come in here into my application and I do yarn start, it will open up and pull up the application, quickly compile it. And you'll see here, when it all comes through, it's going to just populate with what the actual application is. And sorry, I got a bit of jitters here from the application as I've kind of cruised through it. What I can show you here is how that application will actually be assembled. So account balances here is what that micro app would look like. And as you can see, if we start clicking around, the micro app is actually storing the state and passing that back into the pie chart here. So as we click through what our different accounts are, we're seeing what the actual account spending is for that area. All of that application is just being fed and handled by the actual micro app. If I come back into here, I'll run through the actual compile application, so the MyBank application. This one here is just a flat out, and it's actually what you just saw, is just a flat out create React app. You can see when we actually exported that app and we built it in Rollup, you can see all we have and what we're importing is just the application here. Normally you would have a data service that would provide all the data. For the sakes of this demo, we're just providing it with some raw values. But that's all that the actual assemble application has the access to. So if I pull back, open this application, you can see the header is provided by the actual app. The navigation is leveraging the components. So as we open this up, we can kind of see different areas. And we're actually leveraging two different micro apps in here. The investments app, again, is another one on the side. As we scroll through, we're actually going to be able to get state. And as we click, it will highlight where it's getting that information from. That application is just something simple here, and we're just pumping in the headings and the random data. One of the reasons why I like to leverage something like TypeScript for this is so that you can actually see the types, and provides kind of a lot of documentation out of the box as you go ahead and create those applications. So your developers aren't necessarily guessing to what the APIs are for these micro apps, but they're just able to see the properties that need to be pushed into it. So as you could probably imagine from Doug's little drawing there, we're missing one application. We actually don't have the credit card application. So what I can do is I will walk you through very briefly how you could establish that as one of those verticals. I'm not going to be writing any code necessarily, but what I will be doing is stepping through GitHub, and this will all be available on GitHub for you to kind of go through yourself. So let's get started. So on the first kind of step, all we're doing is we're still taking that very basic kind of app structure, and this is more like your boilerplate. So this is just a very simple, customized, very minorly with Rollup, but is your create React app with Rollup integrated and TypeScript. So as you can kind of see inside of here, it's just providing you the basics. If I were to come in and actually create or open, and again, one of the reasons we can actually start this so quickly is because our components are being leveraged. That design system gives us a really quick and fast and easy way to be able to kind of create these apps. and without having to worry and think about what the button's going to look like or what a table is going to look like. All we have to know is how it works and reacts, and then what the API and documentation would look like. So very, very simple. Very simple roll-up configuration, very simple lint. There's really not much to this first initial application. If we go to the next stage, you can see that we've been able to create this component wrapper, which is very similar to the other application that we saw. It's been customized a little bit because we wanted to handle the data differently and populate the table a little differently than our other micro applications. But the neat part about calling this out is that I'm not actually interacting with any of their other applications, and I can make my micro app work the way I need it to, but leveraging components that are always going to look the same. Inside of our application, we've just done something very simple to try and get the application, to get the table out. We're not necessarily changing much of the application. We're just trying to get the table defined in there and displayed. So as you can see here, it's updated on the fly. That data is in there and it's being rendered as required. For the next step, we can add in that A tag at the bottom, that link, so that people can learn to or be directed to apply for a credit card. So you can see here, we've simplified it out a little bit. Table stays the same, but we're going to, for this one, we're just going to create our own React, apply for a credit card application. This is all very contained inside of that application class. There's a really great kind of scope. I can look exactly what I need to do and what I need to build here. And as you can see, it's kind of reconfigured it. It's rebuilt itself as kind of necessary. For the next one, we're going to get a bit more exciting. We're going to get to add a few more components, and we're going to be able to sort of play around with the layout to make sure that we're going to fit the rest of the styling and everything kind of required by design. So we've added in such things as the My section, which provides some good accessibility. We've got the My Grid here, which would be the grid system provided by the design team so that we're not breaking that. We have a property here where we can sort of say that we need this to be a full length. And then we've added in things like our header and whatnot. The cool part about this is there's not much styling that's necessary. I'm just able to pull all these things and kind of drop them in as you would normally a very easy component library. And this gives us our basic page structure. So you can see that that has updated and it's changed a little bit. So for the next step, this isn't going to necessarily work in creating, we need to kind of create that API so that the rest of the application can work within it. So we need to abstract out some of these data points, or what we want our team, the credit card team, to be able to say provide an API to the assembler team. So apply for a credit card, we don't necessarily want that hard coded, and a lot of these data values and headings, we don't want those hard coded either. We want those to be, say, added in later. It might change by environment, might change as part of your dev process or your DevOps process, but we need to kind of abstract that out a little bit. So as you can kind of see here, we're adding in things like our constructor, where we're going to be able to get props passed in. We've added in the right type safety and things like that at the top here, and we've added in some default values because some of these things are optional. So all this has been kind of swapped out now, and the only thing that's actually hard-coded at this point is the heading of the top there. So in order to kind of make this work, we still need to leverage that sort of micro app idea. So now we can actually leverage the index.tsx file. And you can kind of see here that it just takes it as a regular application, but we're still passing it in. So we now have, rather than apply for a credit card, we have apply for a Visa, and we have things like Visa and a New Balance there. These are options that can just be stubbed out. So if I come back to the application, you can kind of see it has recompiled and reconfigured. So it's completely sort of a live data that we can pull in. Now the next step is kind of the most interesting part, is we no longer need, we are kind of done with our micro app, so we need to be able to integrate this into a regular React application. So if I do this, none of this is actually going to change, but what we're going to see is the actual application change here. So that's something as simple as importing the credit card application up at the top here and importing the style sheets that might have been included in that. And that can just be something, maybe the team had some animations or something that they needed to do and they needed to pull in. And in this case, what we've done is we've looped in that component and we've added in just the stubbed out data again. If I come here to my regular React application, start up the regular React application. All of this will be compiled and all of those applications are brought in, and you should see an account, an investment, and the new credit card application that we've created. And you can see all of them coming in together. So all the interactions and everything are done here. And it's something as simple as that. Now, I know we don't go into how the data would get to that point. I think that's another very interesting topic. But I think that concludes what I would walk through in this one. We will attach the GitHub link. And if you do have any questions, please feel free to reach out. Thank you very much.
Thanks a lot, Tim. I think one of the most important things that that you need to think about as we go through, and let me just pull this up, as we go through and talk about this is, the example Tim did here was with React, because there's a lot of stuff happening. This is, simulating the work of 3, 4, possibly 5 teams when you take into account managing components, managing the global application, and each feature team as well. So, when you think about what that means for your business, this is where you have to make those decisions about what's the right choice for your application. How can you break your application up into those vertical slices that make sense? And also from a technology perspective, again, like I said, Tim used React, but you could just as easily use Angular for this. You could use Vue or a combination of those, because you can mix and match the applications. Basically, at the end of the day, you're importing the different micro apps into a more kind of like very thin global app, and it's JavaScript at that point. That does come with a couple of caveats, though. So let's go through what that means. So large apps, especially ones where you're using multiple frameworks, where you have a team where maybe an account they're using Angular, in credit they're using React, and maybe Invest is using Vue, or a combination thereof. That can really balloon the size of your application. So having a caching strategy, a well-planned caching strategy is important. There's significant effort that would go into making that work correctly with how applications are today. Specifically about application size, we have Angular 6 today. Angular Ivy will be coming soon, which promises a rendering engine that will help with some of the page weight sizes that can happen with an Angular application. But regardless, even when you think about having server-side rendering and initial load on top of caching, etc., there's ways that we can work around some of those challenges to really give you the added benefit of being able to get to market more quickly. Custom elements. So Tim showed custom elements here. He alluded to this fact. Custom elements work well in modern browsers, and there's polyfills for the ones where they don't. One of the challenges is actually with React and Angular JS 1.6. They support web components up to a certain point, but there's some advanced use cases where you have to do a little bit of extra work, and you saw Tim working around some of those things in the code examples, and you can check that out on the GitHub repo. So I just want to reiterate, this multi-framework idea makes sense for teams with, hundreds of developers across multiple teams with, different ideas of working. But that doesn't necessarily mean for smaller projects that it's the right choice. So you have to figure out for yourself what is that right solution when you're looking at vertically slicing your application. Maybe it isn't using web components, and it just is organizing your React applications in a way that allows you to build components independently of each other. That might be enough for your application. So you really have to, don't just do it because you can, do it because it's the right answer for what you're trying to solve. And lastly, we talk about this like, oh, just reorganize how your teams work. If you're the CTO on the line, then great. You probably can make that call a little bit easier. As developers and managers, though, don't underestimate how much organizational change has to happen to kind of reorganize around this type of solution. A lot of CTOs that I talk to and we talk to at Rangle, really want to organize around a single solution, a single framework, for all the things that they're building. And that's not necessarily a bad thing, but you really have to kind of, be aware of that if you're going to go out tomorrow and say, hey, we should, use whatever we want and use web components. It might be a little bit of a challenge there for you. But regardless of which approach you choose, make the conscious decision to create a clear separation of features and concerns within your application. Use that immutable kind of architecture. And really, it'll help make your life easier as a developer, as a company, and it'll allow you to move more quickly on the things that actually matter that we talked about at the front. So that's what I had to talk about today. I just wanted to put it out there. We might have some questions, so I'm just going to open up the questions tab. Let me just read the first question here and we'll figure out which one of the two of us is going to answer it. So the question is, do you use any scaffolding tools or build your own config from scratch in your products?
I think I can take that one. I think it really depends on the application you're building. When you start looking at something like Create React App, it's fantastic for that POC type level. It gives you a lot of things outside the box, or sort of in the box, I should say. The problem is that usually applications tend to grow a little bit, and they can become a little hard to kind of maintain with inside that actual application. I know we look at, and we're very big proponents to the Angular CLI. I think that has worked really, really well for Angular, and I think that's one of the big encouragements that we have here. And we don't tend to suggest people eject out of that one, but we do find that with Create React App, it's great for getting started, but to some level you will need to eject and kind of work with inside of that. And that's basically due to the build process. I hope that answers your question.
Absolutely. Okay, so second question. Can you suggest some resources to check out on this topic? Yeah, there actually happens to be a website called microfrontends.org. So they explain some of this as well. They come at it from a web component perspective. So when you see the examples on there, they're all straight web components. So we've added in some additional kind of React and using Stencil, etc. The examples you see on that website are just straight web components that you're writing yourself. Okay, next question. How to manage user actions that are required calls of various parts of the application? Do you store all the data as a global store all the time? So there's a couple of different ways you can approach this. You could have a global store, so you could have like a global state in the thin application layer that you see kind of at the top of this diagram. You don't necessarily have to do that, though. Again, like I said, there's lots of different choices that you have when you build your architecture. So a lot of, like when you look at Angular, React, and Vue, state management for those is all done in that through Redux, etc. is basically a global state. It's a single application state. Different ways you can pass information, though, with a micro front end is you can have that kind of global application or the actual like account application itself, watching for changes on the properties on the DOM itself. So when you think about maybe I have account and it has I don't know, like a balance example on it. It says $100, and that changes to $200 within the DOM, the actual account application itself can recognize that and then update itself accordingly. But you also have to get information out the other way. So you can use custom events to push information out and have other applications listen for those events. So you don't actually have them directly talking to each other, but you can have them listen for common events. So if you don't want to have that global state layer on the top, you can have it so that they're talking with events. Hopefully that answered your question. Okay, next question. Do you know anything about ready solutions like Canopy Tax, Single SPA, or this one from Mosaic 9? Is it worth it? To be honest, I haven't looked at them personally, but if they get the job done for you and they meet the needs of what you're looking to do, I'm sure they're great. There's a lot of great solutions out there, lots of different ways you can approach this. A lot of times when we're building here at Rangle, our clients have very specific requirements, and it's usually, you know, difficult software with difficult challenges. So, you know, often the approach that we're talking about is what we might do, but, you know, if there is a template out there that works for the application you're building and it's open source and, you know, it's you know, free to use, so to speak, I would say absolutely go for it. So, but I will check those out and I can maybe post an answer back to Twitter. How about internationalization, IETN? Can it be handled with micro frontends? All examples are usually hard-coded text. So your application would work in the same way as it would with anything else. So if you had dynamic data, you know, if you want to avoid hard coding, the applications themselves, you know, would work in the same way as you'd build anything else. It's just that we've divided it up into vertical slices. The how you handle IETN or anything else, you know, accessibility, anything, doesn't not necessarily change. It's a little bit more about you're using the browser to communicate between the applications, like I mentioned in the previous question, but you're still taking the same approach. I think that's the question that you're asking. So if not, you know, feel free to ask again if I haven't answered it. Okay, so it doesn't look like there's any more questions. I want to thank everybody for coming on the webinar again today. On behalf of Tim and I, you know, thank you for taking, you know, time out of your day to listen to us talk. And again, if there's any other questions, feel free to reach out to us directly. So thank you very much.